one of the things that's important to know about Babylon is where is it? It's look, the remnants of the city are located next to Hilal in Iraq. Other important centers of learning back then were Nineveh, Babylon, and Uruk, which are now basically Basra and um, I wrote that one here. So I put this big list of former inhabitants of Babylon just to give people an idea. I don't know how to read them all. No one really should, but um, get a sense of how long things have been around. Babylon has been around. 27 BCE. Um, Hammurabi made Babylon city capital in 1700s BCE. Hittites and Kassites took over. Nebuchadnezzar the first to control Assyria, Aram, Chaldea fought to control the capital and surrounding region. So you get a sense of, all the way down here to Alexander, who had the honor of dying in Babylon shortly after he took it over. After him was the Seleucid Empire. These were basically his generals, and I think one of his children. I'm not sure about that, but generals after Alexander kind of divvied up the provinces. But the point is that you can't really say the Babylonian astronomers because there were lots of them through lots of different time periods. That's kind of the point of this slide. Next thing I'd like to talk about is we know that the Egyptians. What about the Egyptians? They had pretty impressive um, buildings, but they didn't leave the records that the Babylonian astronomers did. Some of their architecture speaks for itself. For example, here you see one little shadow, and that's the summer solstice. The second shadow represents the equinoxes. The third one represents the winter solstice. And they always knew what they're doing because the shadows kind of bear out. It's pretty amazing. The difference, though, is that they didn't. We don't have any records from them writing things down. They used different technology than the Babylonians did. They used largely papyrus scrolls and other forms of biodegradable material, flammable material. The Babylonians used clay tablets. So something said about the permanence of rock. Back here, the Egyptian history was roughly 2500 BC. It's kind of they're building these pyramids during the same time as the Babylonians were doing things, writing things down, recording things. But like I said, it just didn't leave records of the observations. Go back to Stonehenge, another, in this case, Neolithic Bronze Age monument, calendar actually. Pretty clear that the builders knew what they were doing. So now they figured out how to lift these 22-ton rocks on top of each other. A good 15, I think it's like 30 feet in the air. Pretty skilled technicians. But again, I'm not even sure these folks were writing anything, much less stuff about astronomy. They knew the astronomy. They knew when it was time to plant and whatnot, because they were farmers and they were hunters and gatherers. But no written records have come down to us from these master builders, as I said. The earliest astronomical records of the Babylonian people kind of date from the Old Babylonian period. There's a book called the Enuma Elish, which was the reference. It's the creation myth. That's what it is. It's the creation myth, and it's where they introduce things like Tiamat and Marduk, order and chaos. Tiamat's chaos. Um, the text is 7 tablets long. It's all in cuneiform writing, which is basically you take a little stick of bone or wood or whatever, and you tap it into damp clay. And once it sets and dries, it's pretty permanent. They do break, unlike it's just one of the drawbacks of this. You have to be pretty heavy duty shelves. But we see that they already divided the year into 12 months. 3 stars, actually, many of them are planets to each month. References to phases of the moon, things like that. But most importantly, it's really the creation myth. The Babylonians wrote down the Kassite period. We start seeing some really interesting things. They recorded 21 years worth of rising and settings of Venus. Each of these is accompanied by omens or prophecies. It's really important to understand that all of this stuff was really, it's not astronomy yet. It's really just astrology. They really want to know what, when Jupiter moves across the sky, what does it mean? What does it foretell? And really, it's not, it's just the Babylonian priests of the time really wrote this stuff down because it was important to them for their religious beliefs and their prophecies. The Enuma tablets, again, 70 tablets, time of omens, based on celestial phenomenon, lunar motion eclipses, star and planet sightings. So this is really a step up. This is actually science. I mean, they're recording data. That's what science builds itself on. Scientific method is all based around gather data, evaluate it, come to a conclusion. I'm not sure these guys got the right conclusion though when they were all worried about whether it was time to go to war or whether it was a good time to be supporting the king or not, whatever. It's kind of fun. So this is where we think that the oldest surviving star lists come from is this Six Dynasties period, 1100 BC to 700 BC. Careful lunar eclipse records. It's believed that these guys discovered the 18-year Saros cycle of lunar eclipses. And that's a pretty amazing thing because you have to go out and study the sky every night for 18 years straight. Well, okay, maybe not straight, but pretty much you've got to get your data. And they did. What's the Saros cycle? I've got another slide about that coming up here in just a moment. I'll talk a bit more of that in a second. During the reign of Nabonassar, as I say, the quantity and quality of the records increases, and it's pretty amazing. So Saros cycle. So if you look at the moon on an eclipse or any night, really, it doesn't have to be an eclipse, really, but 18 years later or 18 years before, it will look the same in the sky. The moon will be where it was, and if we actually look at the diagram here, count 1, 2, 3, all the way down to here, 18 years earlier or later, it's on almost the same spot as it was up here. And this chart actually tracks with different kinds of eclipses, as well as just the fact that they were there. It's pretty. This isn't obviously the data they recorded personally, but it's a modern interpretation. It's 18 years. The years are right here, but you can tell that it's pretty amazing stuff. It's important to note that Hipparchus, Pliny, and Ptolemy also knew about this phenomenon and used these kinds of data from the Babylonian cultures to write their own stuff. And I'll show more about that a little bit later. And it's important to note that precision, while not perfect, is stunning, given that they didn't have smartphones or calculators even or anything else. All I had was clay tablets and little sticks. The Chaldean and Assyrian period. Oh boy, these guys are awesome. All right. So the reign of Ashurbanipal, collected library and older records from Sumerian, Babylonian, and Assyrian sources. He really did build a big library. And in that library, we found somebody, I'd have to talk about that later, but the scientists and astronomers back about 100 years ago found a thing called the Molapen. And this is it's a Babylonian astronomy textbook for all intents and purposes. It had all kinds of knowledge and information from previous works, and I'll cover each some of those discoveries here in a few minutes. So the Persian period, this is where they really got some information. So they equalized the zodiac. What's it mean? Well, they regularized the calendar. 12 years and 12 months and 7 years and 13 months. Why is this? Well, it's because that's right, 12 years and 12 months. That's right. Okay. So if you strictly go with 12 years of 12 months forever, sooner or later, Christmas time becomes January 1st, then it becomes, March, April, May, June, July. It keeps on going. You have to straighten it out every few years. And the Molepen tablets tell you how to do it. If you follow their writing and whatnot, you can find out, how they did it and replicate it. They applied mathematics to astronomical problems and predictions. It's an important note. It's kind of that sense of science, early science. And the solution period it's kind of fascinating because this is where the mathematical theory of planetary motion around society. So it's just many of you have heard of the Antikythera, the little solar system model that was found off the coast of one of the islands of Greece not too long ago. That was built sometime in the same period as these guys were running Babylon. Um, I'd like to move on to Babylon and astrology, astronomical knowledge. Sure, Babylon and astronomical knowledge. Okay, so yeah, the Molat tablets begin with a list of stars and constellations. So I'd like to go ahead and show you some of the constellations that the Babylonians saw in the sky. This is Pegasus up here. We call it Pegasus. They call it the Great Field. Lots of god names and Anunnaki and the Old One, Star Cluster. That's Pleiades, 45. Steer of Heaven, obviously, they're Taurus. Our Taurus, they're Steer of Heaven. Yeah, the Great One. This is one of their main chief gods. So the stag, the panther, the she goat. I'm not quite sure why the word she is in there. Rams, male goats, and goats, she goats. Not sure. Anyway, sitting dog, wagon of heaven, North Celestial Pole. There's Polaris right there. It's pretty close back then. If you want a more updated version of these charts, there's a kind of a program called Stellarium, and they actually have in their cultures section, they've actually gone in and done what I've done, only they've done it on more recent data. So you can actually see a little bit more updated. Panther, the horse, the goatfish, Capricorn, I think, no. The dead man and the eagle. I don't remember the story behind this. It's kind of interesting why they came up with that. The lion, the crab, the twins. Gosh, these look almost all of the zodiacal constellations that we have today are directly transferred from the Babylonian astronomy culture. Shepherd of Anu, Orion. Anu was one of the great gods, main gods. The frond, interesting. Um, right here in the um, Colon Berenices, Bernice's hair, they have the frond, the furrow, and scales, crow. Crow, that's interesting. Forgot about this. The crow is still known as Corvus today, and it's one of the constellations we look at today. I love this one, the arrow and the bow. And I've actually seen a couple of these at night. It's pretty easy to see. On a clear, dark night, it's really easy to see the shape and where this arrow comes from. And it's pointed basically right up here. The other thing that the Mulap tablets list are dates of heliacal risings of the constellations. So what does that mean? Heliacal rising is when the star or group of stars rises right before dawn, usually. Here's an example. I've changed the dates and times to be more modern. On February 1st, 2010, in Boise, Gemini will be visible low and in the east just after sunrise. Cancer will have just risen. It's essentially a form of astronomical calendar. The Greeks call it a parapegma. I don't really know what the Roman culture called it, but they did it. They use the same format over and over and over again. And after the parapegma was a listing of rising settings. So, and you might ask yourself, well, gosh, they really have this that much accuracy in terms of time? I believe they did. How? Well, they used a water clock. They already divided the night into 12 equal segments, and I'll cover a little bit this later on, but they really did have pretty accurate timings. Why? Why they do this? Again, it comes back to astrology, not astronomy. Because if it happens here, 10 p.m., what will happen next year at 10 p.m.? How much will it shift? It's interesting. You can still do this. Yeah, if you look at this in the sky.org, what's up times PHP, this is you can see the same kind of format for modern constellations and stars. It's cool. So they divided the sky into three bands. That's right. Enlil, Anu, and Ea. I hope I said that right. Enlil is this circumpolar northern star Marduk, planet Jupiter. The way of Anu, celestial equator, Venus, Mars, Saturn, Mercury. We have one southernmost band. These are like Boise even. We've got some of the sky we can see for part of the year. Well, there's three periods they used, and each of these bands is divided into 12 sections. The original calendars that they used, I alluded to earlier, were 12 months, only 354 days on a calendar year. They started inserting a 13th month occasionally to make the seasons match the month. It's kind of like the Romans did the same thing. Remember, September should be the seventh month, but because somebody inserted August, and so they got them out of order. Anyway, the oldest mountain. Yeah, the Mulapin tablets specifically tell one how to figure out whether to insert a 13th month or not. And like I said earlier, during the Persian period, it regulated this in a 19-year cycle. Excuse me. So you're going to start listing. And this is a translated version of a star listing. Here are the times. By the way, the Babylonians use not hexadecimal. They use space 60 math. Um, ever look at a stopwatch? I mean, it's not a stopwatch, a clock. Time is divided into base 60 math. That's where this comes from, right here. So the pi wedges represent the months of the year. Each wedge divided by 3 belts. They didn't quite know where to put the planets because the planets move. Unlike stars, they didn't stay still. Other technologies. The gnomon. The gnomon is a integral part of a sundial. It's the pointy part that tells you what time it is, actually. And water clocks. These guys used water clocks. A water clock is basically a jug of water with a hole in the bottom. And you pour enough water in, and it'll last an hour. Um, why do they use these things? It's used to determine the length of a watch. By watch, I mean a military post, silent watch to protect the town. Length of the watch vary depending on the season. Why? Let's see. In the summer, days are long, nights are short. Your time is opposite. Next section is Babylonian understanding planetary motions. Planets were important to the Babylonians. Marduk Astronomy. It's from the Babylonians that we have the earliest recorded planetary data. About 1400 BC, Venus tablets, mentioned these earlier. In the Mulapin tablets, there's a rough description of synodic periods. Author's astronomical diaries. Conjunction means it's close to that other object. For instance, we've had recent conjunctions here in the Treasure Valley. Jupiter and the moon. Anytime anything gets close to the moon is pretty important. And the beginning of retrograde motion. Did you know that the planets back up in their orbits? The Babylonian astrologers did. The planets generally travel eastward around the zodiac, but periodically they go backwards. They slow down and go backwards. I'm going to show you what this looks like. Jupiter. This yellow dot is the sun. This yellow circle 4 is the planet Jupiter. Right? Notice how close it is to the top star here in Sagittarius. Now it's here's on one side of Sagittarius. It's on the other. Excuse me. Sounds about weird. Go for it. Moving further and further along. Hey, this is banging up. Oh my gosh. There you have it. One little beautiful retrograde motion. Here's where we started. That's banging up again. So these are two important planetary periods: the tropical period and the synodic period. And synodic period is what you measure with rotary motion. Um, and try. So this is an example of the synodic period of Jupiter. There was a synodic period of Venus. 45 days, 90 days on Earth, 35. You know. And that's the outer blue circle is Earth, the inner green circle is Venus. And at this point, there's 591 days to be back where it started from, where I was lined up here. Up here. They also, this is how you could tell that Venus is actually around the sun and is not two objects, but one. Um, a lot of early cultures had a hard time understanding why, explaining why Venus moved the way it does. And I've cut this section out, but well, why study retrograde motion, elongation, synodic travel periods? Well, if you had hundreds of years of observations, there's something in the relationship between synodic and travel periods. If you long enough, the pattern repeats itself. Not perfectly, but close. Remember I talked about the solar cycle earlier, 18-year cycle of the moon? Well, these are the planets of the time. Venus 8 years, 6 years, Mercury. What this means that if you saw Mercury tonight, let's use a brighter object. If you saw Jupiter tonight in the night sky, if you jump forward 83 years, give or take, you will see Jupiter in the same place in the sky against the background stars as you would today. It's with this data that predictive models of planetary motion can be created. The goal year texts are essentially a big set of texts that show the dates, the following criteria. You can see on the screen there. These are lunar eclipses, beginning motion. So they developed a very clever mathematical construction. You didn't need a bunch of data. So the ancient Babylonian society valued astronomical observation. To them, this data was a job, quite clearly a job. Not only was it a job, it was a hereditary job. It's rumored that, written down that the Babylonian or Chaldean astronomers of the day could, they would begin training at a very early age and keep working at it all through their life. When their father passed away, then the son would often take their place. It's very, tradition very different. Yeah, right here. Okay, I'm back. So, how do we know the Chaldeans and Babylonians passed data down? Well, this is the text from the Enuma Anu Enlil, written in 15, estimated to be written around 1595 BC. And what you're looking at here is this: on this day of this month, and his white moon god or votive offerings. The- Now, compare that with this text from Claudius Ptolemy, AD. Color related to eclipses. Black, green, white, Jupiter, reddish, Mars, yellow, Venus, variegated Mercury. So it's pretty clear to me, anyway, that that even people like Claudius Ptolemy, who wrote the greatest work of ancient astronomical calculation and data, obviously had access to a translation of this data from the Chaldean Babylonian people years and years before.